Hello, good morning. We are discussing various hydraulic structures along the canal system for enabling effective irrigation to the agricultural lands. The major hydraulic structure dam, the cross regulator, the head regulator, the tank sluice, the direct sluice, the canal drop. This cross regulator is otherwise called a canal regulator. Canal regulator. When it comes in the picture, when a road or a natural drain in a road crosses the canal is at the lower part, over that you have a road. So the canal is flowing underneath the road. So sufficient. That part of a road shall be supported. Usually for small canals, that support part is called a culvert. Culvert is small supporting system with an opening, just like a box. One type of supporting system is called a box culvert. So that will facilitate opening of water for the canal to cross the road which is above the canal. So you have the canal, you have the culvert, and perpendicular to my view is the flow of canal. This is the road, canal like this through the culvert. For a canal regulator, this culvert has to be wider because canal, especially for main canals, meters of length will be there for the width. The width itself, canal will be very wide. So to accommodate that, you will provide piers in between. Not only in a culvert, you will have support only at the ends. It will be a single opening. But in the case of canal regulator, there will be multiple openings. Each opening is facilitated by the support of piers or pillars, vertical members. So there will be 2 or 3 or even 4 openings whenever the bed width of the canal is small, the opening is small, and you will have a side wall here, and in between you will have the piers. Between the piers and at the end you have the pier and the side wall. Usually these two side walls, I told you yesterday in the case of arch dam, for all hydraulic structures there are 3 mandatory components to hold these hydraulic structures with the soil, with the embankment, to catch the embankment, to hold the embankment with that of the hydraulic structure. Hydraulic structure has to be connected with a transition with the 3 major components, which will be a mandatory which is the mandatory components for all hydraulic structures, for most of the hydraulic structures. That is called the abutment. The abutment is the part which holds the hydraulic structure. Then there will be a tapering component, usually of masonry or concrete, which is known as the wing wall, sloping downwards. Then a thing connecting the embankment with the wing wall known as the return. So there will be 3 components on both sides of the hydraulic structure: the abutment, the wing wall, and the return. Usually the wing wall will be sloped downwards because the embankment is sloping downwards. Since embankment is sloping downwards, wing wall also has to slope downwards. Return will be level. It is, even though it is called return, it will be a level return. So you can see the shape. This is the return. This is the sloping. I am showing in the plan. Now the slope is not coming, but the deviation is coming. There are two things for any element. One is the slope, another is the splay. Slope and splay. Slope is the angle, the inclined angle with respect to horizontal. Whenever the angle, for example, you take this line. Now this line is horizontal. Suppose this line is like this. Then it is having a slope. It is inclined to the horizontal. Now it is 0, the inclination 0. Now it is having an angle. So this is slope. The deviation of angle with respect to the horizontal is called slope. Whereas this can have a tilt in this way also. The horizontal plane, it doesn't have any slope. It doesn't have any angle. But now this is parallel to the camera or parallel to the plane, you can see. But now it is not parallel. So this angle, the angle with respect to the vertical, angle with respect to the vertical. Now with respect to the vertical, just see there is no angle. But if you just turn, it is having angle in the horizontal plane. It was 0 here, but when it comes like this, it is called as splay. Splay with respect to the vertical plane. When it is there was no angle. Now it is having an angle. This angle is the vertical plane. Vertical plane, you just see, this is the vertical plane. There is no angle. When it like this, with respect to the vertical plane, it is having an angle. That is called as plane. So now we just revert back. You have a level return. Level return. It doesn't have any slope or a spline. Then the other part is this you are showing a splay. It is having a splay as well as a slope. A splay as well as a slope. Now in the plan you will see that in the top view you will see the splay. When you draw the top view of the structure, you will see the splay. And when you see the front view, you will see the slope. Always it is the case. The elevation will give you the slope, the front view will give you the slope, and the top view will give you the splay. So this is the return. Then you have a wing wall, then you have an abutment. So abutment, wing wall, return. Abutment, return, wing wall, abutment. Again wing wall, return. So it will be just like this, coming straight, again a wing wall, the other side, upstream side, and the upstream side and the downstream side you will require this. Then only it can hold the soil. What is the material inside this pair of returns and pair of wing wall and the abutment? Nothing but soil, over which you have the road. Over which you have the road. So abutment, wing wall and return on upstream side and the downstream side are mandatory components to hold the hydraulic structure in position with the soil and to confine the soil, to protect the soil. That is there for all. Whenever you are designing a hydraulic structure, design of these three things are mandatory. So abutments, two abutments, then you have the total width of the canal will be split to accommodate with the limiting the velocity. Whenever velocity through this is more, there will be scouring. There will be scouring and it will experience a great pressure on the piers. So usually 2.5 meters per second. The velocity will under the road through the openings will be restricted to 2.5 meters per second. So once you fix up the velocity and once you know the discharge, discharge is equal to area into velocity. Discharge is equal to area into velocity. You have fixed the velocity, you know the discharge. Cubic meter cube per second. The discharge of the canal, it is a controlled flow. So you know the discharge, you know the velocity, you can get the area of the opening. How much area? Then you divide diplomatically as far as possible equal areas. So symmetrical loading. All openings will be equal. And you have to design the abutment, wing wall and return on the sides and the piers in between. And the water has to be regulated. You have to regulate the water. You cannot open the water completely. So you will have a road and there will be a raised portion on the side of the road which will facilitate the operation of the shutters. You will have, initially it was wooden shutters in the English period. All the shutters were of timber. Now you have switched over to steel shutters, very strong steel shutters. You will have a screw gearing arrangement manually with a steering wheel, screw gearing arrangement, by which the shutters will be raised or lowered. Since it is operated, it is operated up and down. The regulators are called as regulators because they control the flow to the downstream of the shutters, upstream shutter. If you want to completely close, water will get stagnant. So water will get head up so that the neighbor on the upstream side of the canal can be regulated. After some time, you gradually open that, so the downstream side. Sometimes you may have to repair the downstream side. There may be regular maintenance. At that time, water is there. So one purpose of the regulator is to regulate the flow of water to the downstream. Second, maintenance operations of the downstream. And to facilitate the road traffic above. So here, the canal regulator, there may be canal regulators, sole canal regulators without roads. But if a road crosses, then it is advantageous to couple the road with the canal regulator. So you have canal regulator with the road bridges or without road bridges. Anyway, the canal regulator will have a top portion as an operating platform where the shutters will be operated to regulate the flow. So canal regulator is a very common hydraulic structure with the road. And once the road is perpendicular to the direction of flow, when the road is perpendicular to the direction of flow, that's the best.
Rural water supply is about getting the right amount to the right place at the right time. It sounds simple, but with canals, it's a lot easier said than done. Manual control gates have meant managing water efficiently is almost impossible. It's just too difficult to keep up. And without proper measurement, there's a lot of guesswork, meaning spills and running short are common. The flume gate changes everything. Here's how. Firstly, the flume gate uses internal digital sensors to accurately measure upstream and downstream water levels, and together with a gate position sensor, it precisely calculates the flow passing through the gate. A range of automated control options means the flume gate has the flexibility to meet your operational needs. To control flow, just choose a flow rate and the flume gate will move to achieve it, even with fluctuating water levels. Or set the flume gate to keep the water level upstream or downstream constant, and it will change the flow it passes to maintain the water level. Plus, the flume gate's remote technology means all of this can be managed from the control room, or even from home. And best of all, the flume gate's networking technology means they can share information with each other to achieve system-wide objectives, enabling a whole canal network to be autonomously managed, eliminating spills and providing a responsive, efficient supply service.
But in certain cases, the alignment of the road will be in such a way that it will be at an incline, it will be inclined to the direction of the flow. The bridge cannot be normal, it will be inclined. It will take more length. At the same time, the nature of force and the component of forces will be different. At that time, sometimes the shutters, since the shutters cannot be normal, you will just stagger the shutters to make it normal. If it is the road itself is normal to the flow, all the shutters can be on the same plane. Suppose the road is skewed, shutters also will be accordingly kept to facilitate the direction of flow normal to the shutters. That is the advantageous thing. So that at that time, the operating platform will be in such a way that the shutters are not in the same vertical plane, they will get staggered. And that type of bridge which is inclined to the flow is called a skew bridge. Skew bridge. So road is skew coupled with the canal regulator with the top platform for operating the regulator. So canal regulator is same thing, is nothing but the cross regulator. The cross regulator, same design. Head regulator also it's similar to cross regulator, only thing that the road traffic may not be there because it is kept at the bank of the canal. So the bank itself will act as the road, inspection road. So you have the head regulator, which will be the head regulator will allow only the excess water. So sometimes you don't require any regulatory arrangement for the head regulator. You just have a weir-like structure or a hump which will store water up to that level, and whenever the cross regulator is not opened fully, the excess water will spill over the head regulator and enter the river. So head regulator facilitates overflow of excess water in the canal to the river. And weirs, check dam. Nowadays you have to store water along the river. To pool water, you have check dams. Check dams are nothing but very small dams made of masonry. Or sometimes you have temporary check dams piling up sandbags to facilitate the upstream irrigation or upstream water supply. Check dams are also, when it is permanent nature, it is also a hydraulic structure. It is nothing but a body of the dam which around 1 to 1.5 meters high. So the river, when it is having less water, you will, in between, you will store water by raising the bed to a height of 1 to 1.5. That raising process will be done by a masonry structure known as the check dam. And water, when water rises more than 1.5 meter, and you can have nowadays we have a regulatory arrangement also. Suppose you want to take water after 0.5 centimeter, you have notches. So through the notches, the excess water will come to the downstream side. We will continue tomorrow. Thank you very much. God bless.